In this video I'm going to talk about water channeling and show how I install water channeling. So water channeling is the material you'll put in the bottom of the boat, usually in the outboard, so not in the center. And what it does is it channels the water into the center of the boat so the boat doesn't lean to one side, and it also makes it so the pump can pump out water more efficiently, and the pump needs less total water in the boat before it can pump. Because if you look at the side of a pump, you can see you'll need a certain height of water before the pump starts actually moving the water out. A pump like this, really about 3/8 inch high will be about as low, or that's the minimum height that the water needs to be before the pump will actually move it out. So with water channeling, because it kind of raises up the bottom on the sides, there's less total water that needs to be in the boat before the pump works. So this is Radetzky here. So the water channeling is the white material here. It's a two-part urethane material called ultralight that I just mixed together, poured in there, and it works quite well. Other material people use for water channeling could be balsa wood that gets fiberglassed over, or some people have used like a foam pad, like a floor mat type material. Generally something light that will help displace the water towards the middle. General strategy for water channeling is to make it between about 1/4 inch to 3/8 of an inch along the center of the boat, and then raise it up in the stern, like you can see here. So in the stern, that's probably closer to 3/4 of an inch there. And then also in the very bow. This boat, because the bow is so small, it doesn't really have much, but on a larger boat, you can fill in the first portion of the bow, especially the portion that's kind of inaccessible or too narrow to put other components in. So the focus of this video will be installing the water channeling in Scharnhorst. Since the last video, I've gotten the drivetrain pretty much installed. So I got the main drive motor and then the outboards, and then I also got the rudder mount. So there's the rudder servo mount, which also is 3D printed, and it has the rudder posts, which are these vertical portions. So this is typically the way I'll sequence my builds. I'll cut out the hull first, then I'll install the drivetrain, and then I'll install the rudder mount. And the next step will be water channeling, and then after water channeling I'll usually go after the deck. I do it in that order because for the water channeling, if you're using balsa wood, if you install the deck first, the deck will kind of have cross members, so water channeling has to go along the whole length of the boat, so it can be more difficult to install if the deck's in first. The reason to get the drivetrain components in before you do the water channeling is you can see that these obviously will interfere with where the water channeling goes. And then also the water channeling would probably go, on top of the shafts. So while it's possible you could do, say, like the bow water channeling or a portion of the midships water channeling, it's really just less chance there's going to be an error if you do the drivetrain first. One thing you'd want to be careful about is if your hull is like bowed in, because some hulls might bow in because of the mold shape or contraction when the fiberglass cures. So if the hull's really bowed in, you'd want to kind of make sure the hull's at the right width before you put the water channeling in, because it could kind of separate in the corners if you do the water channeling first and then install the deck, which ends up pushing it out. Or, opposite, if the hull's too wide and has to suck it in, the water channeling could get in the way, because the hull will bend in these corners. You want to make sure you know where the pump is going to be, because you want to make sure the water channeling doesn't interfere with the pump body. So in this case, you can see I put the pump between the outboard motors here. So I'm actually not going to really have any water channeling beyond this line, because it'll get in the way of the motor. So there'll be plenty of room. But on other boats, like most boats, you won't have these outboard motors on. So you'd have the water channeling run past it. So you'd want to make sure you know how you're going to mount your pump, so the water channeling doesn't run in the way. In this case, for this mount, I'm going to use like two vertical posts that are going to, those holes will go around, and then that's it, because that'll be adequate to hold the pump. You want to think about the weight of the ship relative to the max weight once it's fully done. So if you have a ship that's really close to its max weight, then you might want some more water channeling than a ship that's going to be lighter, because the water channeling determines how much water needs to be in the boat for the pumps being effective. So the more water channeling you have, the less water you need for the pump to be effective. Now that's one factor, but a competing factor is stability. So if the water channeling's too high, once the water gets up, so it's going on top of the water channeling, then the boat will be less stable than if the water channeling was lower. The way I like to think about that is just think of the weight of the water. So to determine a boat's stability, or to maximize stability, you want heaviest things lowest in the boat. So water is relatively heavy. If it's higher up in the boat for the same given amount of water, then the boat will be less stable than if the water channeling was lower. So it's kind of a balancing act. And then you also want to consider that most of your components are going to sit on top of the water channeling. So, specifically like batteries, which are probably the heaviest component in your boat. So the higher the water channeling, the higher the batteries are. Now you could, of course, try to make the water channeling go around the batteries. Some people have done that. But if you use like a kind of normal water channeling height, so 1/4 inch, 3/8 of an inch, somewhere around there, then you don't really need to worry about it. If you're going up to like 3/4 of an inch, you would want the batteries to be recessed a little bit. And it's also important to have some sort of water channeling. So say your battery was, perpendicular to the long axis of the boat. You can just think, just water would have a harder time flowing past it to get back to the pump. So it kind of creates a channel for water to get around all the major components in your boat, because you'll have water coming in anywhere along the length of the boat. A kind of common misconception is that water channeling will give you additional buoyancy so the boat won't sink as fast, but based on my understanding, that's not an accurate way to look at things, because the water inside the boat isn't really in communication with the water outside the boat. So you don't get extra flotation from the water channeling until the boat is completely submerged. Now, if the boat's completely submerged, that would be true. But, I just recommend thinking about it in terms of higher water channeling causes the water on top of the water channeling to be higher, which will be less stable, but it will make your pump more efficient. Okay, so general strategy, I've kind of already started on this, so you can see the lines there. So first, draw a line in the middle, because you want the water channeling to be centered on the boat, and then draw lines at the width of what the water channeling is going to be. I think this width is about 2 1/4, and then what I'll do is I'll just use like a scrap piece of wood and then put a little tick mark on it, and then just use that as my measuring device, because in the hull it can be hard to fit a ruler in there, especially in the bow. So in the very bow, I'm going to fill in up to the line right there. The way to determine that is just kind of putting a bottle in. Even though I'm not planning to put the bottle in the bow, there's still a chance I could want to do that. So you can kind of see that there's a certain limit to how far the bottle can move forward. So that's where I put the mark. For the bulk of the length, it'll kind of be just about 3/8 inch high through the middle here. And then in the stern, what I'm going to do is I'm going to sort of build up this area. So you can see right now it's not really level. So I'm going to build that area up to make kind of like a platform, because I'm going to put the solenoids and the expansion tanks on there. So you can kind of see right now, the solenoid's kind of drooped over, and it would be hard to make a mount that would fit on the existing surface. So if I just kind of build up a platform in this area, that'll make the mount much easier, and then it'll also help keep the water out of the stern. One thing you want to be careful about is where the aft turret is. So in this case, I have it, you can see the mark kind of existing right there. So this is where the aft turret is. You don't want it to be too high there, because your gun tees are going to, you're going to have hoses coming out at the bottom of them, and you don't want them to run into the water channel. So I'll probably leave the area directly under the turret empty to account for that, and then I can always fill it in later if possible. In the extreme stern, I'm probably not going to do much. I could build this up more, but then you'll end up kind of with a pocket of water in this area where the servo is. I might do maybe I'll do a drain pipe or something that will allow that area to drain, but we'll see. There's really not a whole ton of water that could get back there. But in general, it is good to kind of build some sort of ledge in the stern at some point, because that'll help. When you think in a battle, the boat's moving around a lot, so water will slosh around. So a lot of boats will sink sometimes if they don't have high water channeling in the very stern, because they'll go forward to run away from someone, and all the water will slosh to the back, and then the boat will sink. And they won't want to stop because they don't want to get shot more. Which is why I'll kind of build this stern up. And then it also helps when the boat floods with water. It'll tend to pull a little bit more water towards the bow, and it'll get the boat to sink more level than if the water channeling was uniform across the entire length of the boat. You think the freeboard is higher in the bow, so if it sinks, if the water pulls up more in the bow, the boat will stay afloat longer than if it goes in the stern. Okay, so the next step is to sort of build up barriers to kind of contain the water channeling, the feather light. If you're doing a balsa method, the next step would be cutting out balsa to this shape, sanding the bottom, and then you would fiberglass it in here. But in my experience, that method takes a lot longer than the urethane, and I think the urethane comes out with a better end product. So it's kind of a win-win. So I'll use like scrap pieces of wood I have. This is like one of my standard water channel barriers because most boats this length works for the midsection. So I'll build these barriers, and then also build barriers up in the stern and the bow to kind of, contain the liquid. I'm going to show the kind of barriers I created for the water channeling. So two main things I use. Plumber's putty. You can get it at the hardware store. For these kind of more complex areas. So I kind of set up barriers here and here to kind of fill in this area. That tube right there is a drain hole, so the area near the servo can drain. And then this area right here is where the aft turret is, so I'm going to leave that empty for now. And then I'm going to fill in this kind of whole area right here, and I added another drain pipe. It's the first time for me using the drain pipes, but I think it should work. Up in the bow, I cut out a little piece of fiberglass and then used electrical tape to kind of seal it off, so I'll fill in this void. And then I have half of the main section done, so I just some strips of cheap plywood. I just cover it with electrical tape and then kind of seal it off. So the way I do the electrical tape seal is I have it on this second piece here. I ended up kind of overlapping but alternating, so this is like the sticky side on the bottom here, and that will attach to the hull, and then this is kind of face down, so it attaches to the piece of wood. You can see how it kind of ends up there, where you end up with a nice good seal along the bottom. If you don't do this well, or the electrical tape doesn't hold, it will leak out, but it's kind of manageable. You can wipe it up if that happens, but once it starts leaking, it's pretty hard to stop it leaking. Okay, so now I'm going to finish putting the second piece on, get it set, and then I'll be ready to mix and pour in the urethane. Okay, we're just about ready to go. I got all the barriers constructed, finished up in the middle there. It's a little curved, but I think it'll be fine. So one thing you want to check is make sure that the hull's level, both fore and aft, and then side to side. Because of course the liquid's gonna, it's self-leveling, so if the boat's not level, you'll end up with inconsistent water channeling. Now, if you wanted to do like a sloped water channeling midships, you could do that by kind of propping the hull up either way, but this boat, that's not necessary. Another thing I did is I made a little depth gauge, so just kind of marked off 3/8 inch. So I'll use that. Once I pour it, I'll kind of stick it in and make sure it's the correct depth. So here's my kind of staging area. So I use a drill with a mixer because this stuff is, it hardens. So you can see there, Featherlight. If you just Google it, you can find it. The containers on top are kind of extra from the previous large containers I had. And so the first step will be individually mixing up each of them, and then in between clean off the mixer so you're not cross-contaminating the larger containers. Then what I do is I use little cups, and I'll kind of make a mark at the same height on each cup, and then I'll have one of these dedicated to each part, and then I'll have a larger container where I'll pour the two parts in and then mix it up, and then just pour it in. So for this method of water channeling, all the work is really in the prep. The actual execution and mixing and pouring is pretty quick. Okay, I just did the first two pours. I got the aft portion there, and then around the gearbox. Might have gone a little higher than what I was planning around the gearbox, so hopefully it doesn't mess it all up, but if it does, then you can just Dremel away. Looks like the barriers are more or less holding at this point. You can see here I got all the containers mixed up. So the next step is I'll mix another batch and do one of the midsections. So I got some bad news. Looks like this batch I was using is pretty old, over a year definitely. Probably closer to 2 years old. And you can see it kind of started like swelling up, so it expanded more. When the stuff is new, it'll look more like this. This is the last pour, so it probably just hasn't swelled up yet. So this is kind of unfortunate, but the base material's there, so I'll probably just have to, especially these two areas, I'll probably just have to sand those down a bit. What's nice about this material is if you mess up, you can always grind it away or sand it or something. This will take a couple hours to kind of fully cure, and once that's done, then remove the plumber's putty, remove the barriers, and then start the cleanup process as far as cleaning the edges off, and then probably definitely this area where I'm going to use as a platform, probably sand that down a bit. I removed the boundaries. Boundaries held up pretty well. I really had no breaches or no escapes, which is one plus out of this. So you can see the benefit of using the piece of the plywood. You get like a nice clean line, even though it's curved a little bit. That's fine. So the next step, I'll probably just use a Dremel to kind of even these things out. In the middle here, I can probably use a sanding block or something. Looks like the tubes worked well. They're both kind of unobstructed. See that one come out there, and then the one from this area to the main portion of the hull. And then in here, I'll probably fill in a little bit so the tube is at the bottom, so there's no area or no volume below the tube. And then I'll clean up around here to kind of give me a little more access to the bolt holes for getting the motor in and out. You can see there's kind of like a little overhang too, so I'll clean that off. So the water channeling cut and sanded down. See, it's more level. This back part I just did with a Dremel, and then along the length there with a oscillating sander, and then cleaned up the front. Here's an example of a different type of water channeling. This is in the Missouri. In this one I use the kind of more traditional balsa wood with fiberglass over it. So it's the same general idea. I think that's 1/4 inch balsa wood that I used there. It definitely gets the job done, but takes more work than the pourable method like I showed. This will wrap up the video on water channeling. So last couple of checks I'll do. See, I put the batteries in the bottle in there and I just verified that there's still going to be clearance for the deck. The water channeling is not too high. Typically that's not a concern. Just to summarize, this video showed how to install water channeling, kind of explained the principles behind it, what the objectives are, which are to make the pump more efficient with a certain amount of water in the hull, and to control how the water is distributed within the boat as it takes on damage, which will determine how the boat sinks with respect to bow first, stern first, or level. As the build goes on, I might make minor tweaks here or there. What's nice about the urethane is if something interferes with it, I can just kind of grind it out with the Dremel pretty quickly. Not really a huge deal. And then I might add some additional water channeling in some of the areas, some of the smaller areas that are harder to get to, such as in the outboards, around the motors, and then maybe in the outboards around the turret. So I'll conclude this video. The next major step will be installing the subdeck and deck.